Hi everybody, I'm Greg Fishel. Welcome to bonus weather video number 2 for this week, and this was a bit more involved in production than I counted on, so hence the lateness of the hour, but did want to talk to you about a special post that the hurricane forecasting folks out of Colorado State University put out yesterday, speculating about possible reasons why the Atlantic hurricane season so far has been so quiet, especially in light of everybody, and I do mean everybody, forecasting that it was going to be the hurricane season from you-know-where. And so it could still, blossom into an above normal season, but I think the chance of us getting to 23 named storms is diminishing each day that goes by. So let's go on ahead. I just want to share with you some of the highlights of what they talked about. First of all, this is a list of, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 15, 18, 20, about 25 different organizations that put out their seasonal hurricane forecast, and including North Carolina State University was one of those, and everybody went for an above normal season. Now, some of them went for an exact number of hurricanes, others went for a range, and there were no outliers here. Everybody, took the bait, and so if this is going to turn out to be wrong, everybody is going to be wrong. Okay, so why was the season anticipated to be so active? Well, the sea surface temperatures in the Atlantic were the second warmest on record for early August, okay? And so that's one of the fuel sources for tropical cyclones is warm water. In fact, generally anything above 80 degrees Fahrenheit is conducive for tropical cyclone activity or development if everything else is favorable, like wind shear and that type of thing. So no problem there. And then we were transitioning from an El Nino to La Nina, which means reduced vertical wind shear over the Atlantic. And that's why El Ninos are generally associated with suppression of hurricane seasons, and La Ninas are associated with an enhancement of them. And we are sort of in a neutral state right now. We're transitioning from El Nino to La Nina, but we're not quite there yet. And earlier it looked like it would already be in place by now, so that may be another possible contributing factor. And then heavy rainfall in the Sahel region of Africa. And I thought it might be helpful to show you what that region is. And basically what it is the boundary between the Saharan desert and the African rainforest. And so that area that you see shaded there is referred to as the Sahel region of Africa. And this is where these waves that come off Africa typically generate, and it's along that boundary between very hot dry air and not so hot and considerably more moist air, and that's what generates those waves. So possible reasons for the quiet season so far. Now, you may have heard, I'm not sure, but you may have heard if you're a weather enthusiast about something called the ITCZ, which is an acronym for the Intertropical Convergence Zone. And it tends to shift north during the Northern Hemisphere summer and shift south during the Northern Hemisphere winter. And it's actually a convergence zone where you have westerly winds on the south side of it and easterly winds on the north side of it, okay? And so this trough is associated with these waves coming off Africa, but it's been farther north this year than it typically is, and I'll show you in just a little bit why that might have been a problem. Secondly, there has been what we call upper tropospheric warming going on. Now, typically, with any thunderstorm, you want an air parcel to be very warm and moist near the ground, and then as it rises, as long as it's warmer than the environment that it's in, it's going to be buoyant and it's going to accelerate upward because buoyancy is a force, and when you have a force, you have acceleration. But if the upper atmosphere is warm, then the chance of that air parcel remaining warmer than the environment decreases, okay? If it's cold up there, that's no problem, but if it's warm up there, then potentially it is, and the upper troposphere has been very, very warm, and I'll show you that in just a minute as well. Then, the third potential reason is what they call too much easterly shear in the eastern Atlantic. And we often think about wind shear as being a problem when there are westerly winds aloft and maybe less westerly winds down here, or even easterly winds at the surface and westerly winds aloft, and it just tears any tropical cyclone apart because it's trying to concentrate warm air in a relatively small region, and when you have winds blowing from different directions, it just doesn't allow that to happen, okay? So in the eastern Atlantic, there have actually been anomalously strong easterly winds, which is actually ripping some of these waves apart from a different direction than normal. Normally we think of westerly shear as being inhibiting, and it is, but in this case, easterly shear can be a problem as well. Sometimes we see this even in the western Atlantic, where we'll have a tropical cyclone whizzing westward at like 25 or 30 miles an hour, and it's moving too fast, okay, compared to what's going on aloft. And so any kind of shear, whether or not it's increasing or decreasing with height, can cause a problem with tropical cyclones. And then finally, what they describe as recent unfavorable large-scale conditions from the Madden-Julian oscillation. Now, I'm not going to go into a lot of detail on that. You can do a Google search if you're really curious. But basically, this is a wave that circles the Earth every 30 to 60 days, and there are 8 phases of it. And phase 2 is typically the phase that is most favorable for tropical cyclone activity in the Atlantic. And we were in phase 2 during the mid to late part of August, and nothing happened, okay? Now it's forecast to come all the way back around to phase 2, maybe in a couple of weeks, but the fact that it didn't do anything when it was favorable before makes me wonder if it's going to make any difference the next time around. So that's another thing to look at. Okay, so the normal position of this ITCZ, or monsoonal trough, okay? Now here is Africa over here, and here is the east coast of the United States, and so this is all the Atlantic Basin in here. Now, this was a diagram that the folks at Colorado State actually produced, and this white line here is where the trough is typically located. And if you look over at the latitude lines here, it's generally between about 10 and 15 degrees north. But this time around, this season, it's been up here, okay? And so why is that a problem? Well, let's take this zone from 10 degrees north to 18 degrees north, which is where the monsoonal trough, or the ITCZ, is normally located. And then this year, it's actually been between more like 15 and 25. Now we look at the sea surface temperatures, and here is the first zone where the monsoonal trough typically is, and you can see how warm the water is there across that entire zone. But it's actually been a little farther north, and so these easterly waves are coming off the coast of Africa over cooler water, and that could very well be an inhibiting factor in terms of these waves developing into anything. Again, warm water is a key source for the energy that hurricanes depend on, and if the water's too cool, then that simply is not going to happen. Now, in terms of the upper tropospheric warming, 200 millibars is at about 35,000 feet, and this is a comparison of the 200 millibar temperatures this year compared to last year. And you can see that there's a large region here that is significantly warmer than it was last year. So that makes the atmosphere a little bit more stable and not quite as conducive to producing thunderstorm activity. Now, we talked about the wind shear with El Nino and La Nina. If you take a look at this zero line that goes straight up and down here, which would imply basically no vertical wind shear, in an El Nino, you're going to tend to have stronger westerly winds aloft and then easterly winds down here at the surface, which is going to create a lot of wind shear. In a La Nina, the upper level winds are much, much less westerly. In fact, they tend to have a bit of an easterly component throughout the column. And again, that's less vertical wind shear and better chance of the tropical cyclone accumulating heat in that relatively small region. And too much easterly shear in West Africa, and that's what this big blue area is here. Here's Africa, and the United States is, oh my gosh, this is such a tough, it's right over in here. There's the east coast of the United States. So this blue area here indicates where you have easterly shear that is very, very strong. The easterly winds are actually increasing with height, and that is perhaps preventing some of these cyclones from developing because there's too much tilt. Any vortex that is not straight up and down, but actually tilted, that is a problem for tropical cyclones. It doesn't like that. So here is the European ensemble wind shear forecast for the next 15 days, and we're going to take this in 5-day intervals. So this first one goes from September 3rd to September 8th. And here is the zone between about 10 degrees north and about 25 degrees north, where you would typically look for these waves to come off the coast of Africa. So down in here, again, you have this anomalously strong easterly shear between about 10 and maybe 18 degrees north latitude. So that's not favorable. Now we head to the 8th to the 13th. Let me go back here. You see how strong that is there? We go to the 8th to the 13th, and that weakens considerably. In fact, if we take a look at this area all through this zone, it weakens considerably, and then we go to the 13th. I forgot to change the label there. This is the 13th to the 18th, okay? And now, other than this little pocket right here and this little pocket right in here, this entire region has much less vertical wind shear than it did during that first 5-day period. So all indications are that after we get to maybe about the 10th of September, that the overall wind shear pattern with relation to tropical cyclones will improve. And this is why the folks at Colorado State still are confident that we will end up with an above normal hurricane season. But you got to keep in mind that they weren't just going for a slightly above normal season. They and everybody else was going for an extremely, like one of the most active hurricane seasons on record. And the chance of that happening, I think, is diminishing by the day. If we end up with 23 named storms at the end of this hurricane season, there is going to have to be an incredible flurry of activity, the likes of which we perhaps have never seen in recorded history. So I don't want to rule it out, but again, when you look at it from a statistical point of view, the chances of this are going down each day that goes by. So I just wanted to share with you some of the speculation, and one of the things that they mention is they don't think it's any one of these factors that is, reducing the amount of tropical cyclones. It's probably a combination of all 4 of them, and there could even be other factors involved that we don't even understand yet, okay? As much as we have learned about the science of meteorology over the years, there are still things out there that we probably do not fully understand and still need to gain an understanding of. And so nobody is claiming perfection here at all. We know a lot more than we used to, but there is still a long way to go. All right, folks, that's it for now. Hope you enjoyed that. That's bonus weather video number 2 for this week. Bonus video number 3 will be coming up on Friday, and of course the next daily weather update coming up tomorrow. You all have a great Wednesday evening, what's left of it, and we'll talk to you again tomorrow. See you later.